we would discuss as to why we simply don't use only the throttling calorimeter and why we need to use a separating calorimeter along with separating and throttling calorimeter. So this representation, this temperature entropy diagram and enthalpy entropy diagram shows us the processes which are happening in the separating and throttling calorimeter. So A to B is the process of separation. A to B is the process of separation. This happens at constant pressure. There is no pressure drop in this. But in the separation, you are removing certain moisture. You are removing certain moisture, so the steam becomes relatively more dry. So the steam which was wet, you look at these 2 points A and B. A is far off from this G line and B is closer to the G line. B is closer to the G line means B is more dry as compared to A, or A is more wet as compared to B. A is more wet as compared to B means the steam is more wet at A, and then because of the separator, it becomes relatively dry, but it is not dry. If it was dry, it would have lied on the G line over here, but it is not lying on the G line. Instead, it remains wet, okay, but it is relatively more dry. It is closer to the G line. Then what happens in this throttling device is that there is a expansion. There is an expansion from a pressure P1 to pressure P2. Look at this diagram. What is happening here? There is an expansion from pressure P1 to pressure P2. Okay, pressure P1 to pressure P2. And you see that during this expansion, the entropy increases and the steam, it goes into the superheated region. The steam goes into the superheated region. Doesn't mean that its temperature is increasing. Please note, the temperature is actually dropping down. Temperature is actually dropping down, but this temperature at C is more than the saturation temperature corresponding to P2. This temperature at C is more than the saturation temperature corresponding to P2. It means that the steam at P2 is superheated because its temperature is higher than the saturation temperature T2. Okay, so why has the steam become superheated? The steam has become superheated because of expansion. And that is the main fundamental of using a separating and throttling calorimeter. If we had not used a separator, what would have happened here is after expansion, the steam would have remained wet and not superheated. And if the steam remains wet and not superheated after expansion, then, and if we had used only a throttling device, then the state was A, there was no separator, then we would have got A to some expansion at some point. That some point would have been C dash. But that C dash would have been in the vapor dome. It means that it would have remained wet. And if it had remained wet, then enthalpy before throttling and enthalpy after throttling, after equating, there would have been two unknowns. Enthalpy before throttling would be what? HF plus X at A plus HFG. And HF plus X at C dash plus HFG. It means that there would have been two unknowns, X at A and X at B, and we would not have been able to solve the equation because one equation and two unknowns, then that becomes a mathematical impossibility. Okay, so for this reason that we want to make sure that the steam after throttling becomes superheated, we need to dry it first by separating some of the moisture, and then you employ a throttling calorimeter. So that is the reason why we are using a separator along with the throttling device. We are not simply using only a throttling device, right? This is also clear from the enthalpy entropy diagram. You look at it from A to B, which is a constant pressure process. We are moving along a constant pressure line. We go closer to the saturation curve here. And then the B to C is a throttling phenomena. That is, you look at this is an enthalpy entropy diagram. That means B to C would be a horizontal line on an enthalpy entropy diagram. Why it would be a horizontal line on an enthalpy entropy diagram? Because it is an isenthalpic process. Throttling is an isoenthalpy process, constant enthalpy process. So when you move from a higher pressure P1 to a lower pressure P2, okay, there and along a constant enthalpy line, you see that you end up in the superheated region. You end up at a lower pressure P2. We can find the enthalpy of the superheated steam, and there would be one unknown over here, that is the X2, and X2 is determined by this equation. Okay, so this is a concept as to why we don't use only a throttling calorimeter and why we use a separating and throttling calorimeter. So separating and throttling calorimeter is useful if the steam is more weight and you need to then dry it and bring it closer to the saturation curve and then you throttle it. Okay, so this is the advantage of using separating and throttling calorimeter over a throttling calorimeter. I hope this is very, very clear to you.